Hello, everyone, and welcome to today's class where we will be discussing assignment 5. Before that, I would like to ask all of you if you had any doubts or questions regarding the previous assignments or the previous assignment. Uh, yeah, you can speak up, you can unmute and speak up if you want to. Anyone? I remember I had asked you to solve a question regarding combinatorics in the previous class. If I can go back to that question quickly. It was, give me 2 minutes. Yeah. So hello everyone, can you hear me? Sorry, I was on mute, I guess. Can all of you hear me? Great. So welcome to today's class. And before we start off, I would like to ask whether any of you had any problems regarding the previous assignment or previous two assignments. Since we couldn't meet in the last class, I had just uploaded the video on YouTube. But if you have any doubts on that, you can ask me now. Yeah, you can just unmute yourself and ask a question. I remember I'd asked you a question on the previous class regarding the combinatorics. Yeah, this is here. This is what it is. Uh, I'll share my screen and maybe then I'll ask you the question. Okay. So last in the video that I had posted on YouTube, I had asked this question: how many four-letter strings can be made with the letters AA and BB? So what do you think the answer is, and how do you think was your approach to the answer for this? Could someone tell me? Anyone?
I think it would be 4 factorial upon 2 factorial.
Yes. How did you get there? Tejaswini, is it? Am I
Yeah.
pronouncing your name
Yeah, yeah,
correctly?
yeah. Yeah, correct.
Can you tell me
Yes.
where you are from before you begin and what do you do?
Okay, so actually, I'm from Bangalore. I am a student. I'm in. Okay, I'm a third grade. Sorry. I'm a third year undergraduate at ISR Tirupati,
Oh,
Indian Institute of
wow.
Science
Okay.
Education and Research Tirupati.
Okay.
So
That's nice.
yeah.
So yeah, Tejaswini, how did you come up with the answer?
Yeah.
Yeah.
So basically, first I assume that AABB are four individual, maybe like components. So arranging them would give me 4 factorial.
How is
But
that?
then 4 into 3 into 2 into 1,
No, but how
arranging
do you
them. So
get
the
four
number of
factorial?
arrangements.
Just briefly, just a logic so that everyone is on the same page. Yeah.
Oh, okay. Um,
Actually, the answer is right on top
actually,
of that. Yeah.
okay. So like, I think we can just go with the simple counting. I'm not sure what the term exactly. Fundamental principle of counting, I guess. If we go
Yeah.
by that, we get 4 into 3 into 2 into 1 number of
Okay.
methods.
Okay. So,
So
can I
sorry,
just
number of
interrupt
ways.
here?
Yeah, sure.
So, what she's trying to say is that you have four letters, four blank spaces that you need to fill. And when you have the first blank space, you can have four choices because there are four empty spaces and you have four letters. Okay. In the second blank space, you are remaining with three letters. So you have three choices and so on and so forth. So the third blank, you'll have only two choices and the last blank, you'll have just one choice. So given four letters, you can fill up four blank spaces in four factorial ways, which is 4 into 3 into 2 into 1, which is 24. Okay. Am I right, Tejaswini?
Yes, yes.
Yes, now you can proceed. You can go to the next part where you did some division, I thought. Yeah.
Yeah. So, but we see that A and B are repeating twice. So there are two elements that are repeating. So which is
Hmm.
why I divide them by 2. Or 2 factorial.
Two what? Two factorial or just two?
2 factorial, okay. It's equal to 2. So I
Yeah.
just said both of
Yeah,
them.
yeah. So she's divided the number 24 by 2 factorial. Why she's done that is because you have two types of elements repeating twice. Okay. So the you have to for each type of for each repetition you need to account for that, right? For example, if I can just say that okay a oh sorry, suppose I do a b oh no, I think I have to do something differently. So according to just this 24 factorial, if I had a b and a b, these would be treated differently because I have treated the b's very differently when I've just calculated 24 factorial. Okay, but whereas they are the same, because we have two b's and two b's, I can use them interchangeably. So both of these amount to just one kind of string, right? Which is a b, because the b's are not different from each other and the a's are not different from each other. So to account for such kind of double counting, we have to divide what we get here 24 4 factorial by 2 factorial, because we have two letters that are repeating twice each. Okay, so that was a logic behind asking this question as to what to do when you have repeating elements in a and when you have to arrange them. Okay, so the answer for this is 24 divided by 2 factorial, which is equal to 12. Okay. You can read more on this if you just Google on simple combinatorial questions with repeating elements. Okay. And I think this is very important since we have encountered many cases where we have to arrange things which actually repeat also. Okay. So that was the last week. Moving on to this week. Uh, yeah. This week again dealt with probability distribution, some properties, and some calculations. Okay, so how did you find the assignment in general? Could someone let me know? Yeah, it'll be nice if people can admit others because I can't keep watching the screen. If it'll be nice if are you allowed to do that though? Can you actually add people when you see the pop up on the screen? I think it's possible, right? Oh, you can't. Okay. Because it becomes difficult for me when I switch screens and I can't see people when they need to be added. But I'll try my best. I get a warning, so okay, I'll try in doing that. Okay, so let's get on with the assignment. How did you find the assignment in general? Yeah, anyone? Yeah, yes, I agree. Yes, Gayatri, I see your point. I don't think I can make all of you as presenters. I'm not sure how to do that. More options, settings, general. No, I can't do that. Sorry. Yeah. Okay. Yeah. Anyone? Maybe I'll just call upon people if uh, Anandita Biswas. How did you find the assignment? Anandita Biswas. Okay. I see some people are regularly attending, which is nice, which is Bijan, Gayatri, and a few others are regularly attending, and that's nice. Okay, that's okay, Anandita. But you can just, okay, maybe someone else then. Prerna Verma. Yes, Prerna. How did you find the assignment? Prerna Verma. Okay. Riddhi Rani. It'll be better if people can speak up so that we have a more interactive and more informative class. Otherwise, it'll be just me speaking and I can just tell you things and go away, and it won't be fun for either of us.
So for me, some questions were very
Okay,
easy,
can you
but
speak up? Who is this? Is this Riddhi?
no, I'm Gayatri.
Okay,
Gayatri
Gayatri.
Kulkarni.
Yes, Gayatri. Yes, Gayatri. Tell me what. Let us know where you are from and what you do.
Actually, I'm a student of MSc Biotechnology in University of Mumbai.
Okay, that's nice. That's nice. Yes, tell me, Gayatri. How did you find the assignment?
Yeah, some questions were easy,
Oh,
but I couldn't answer questions of Poisson distribution.
okay. Okay. Anyone else? Okay, maybe we can just start off with the questions and you can let me know where you found things to be difficult. Okay. The first question is, for which of the following distributions are the mean and median equal? Yeah, anyone? Anyone with a guess or a reasoning as to what the answer is and why it is? So,
Normal distribution.
normal distribution. That's it? No other distribution? We're talking about mean
Uniform
and
distribution
median.
maybe.
Sorry?
Uniform distribution also.
Yes, can I know who this is? Can I know who just answered? Can you, before answering, can you please tell us your name and what do you do and where you're from? Because it'll be nice if everyone knows each other. Yeah, so someone just answered. Yeah, someone just answered that the first question, where the mean and median are equal, uh, they're equal for the normal distribution and uniform distribution, which is correct. In both distributions, the means and medians are the same. Actually, even in binomial, they are very similar, the mean and median, but there's a slight difference. And I won't go into why they are very slightly different because that requires some mathematical rigor, which is beyond the scope of this class. But yeah, for both normal and uniform distributions, the mean and median are equal. Okay. The next question is, if x, which is a random variable, is uniformly distributed between 0 and 100, close interval 0 and 100. Can anyone tell me what this means? What does close interval 0 and 100 mean? Can someone tell me the meaning of this? You know, there are two kinds of intervals, right? Open interval and closed interval. For example, um, something like, I think I need to admit someone. Yeah, yeah. So, for two numbers can have, for example, say an open interval. Sorry, say I say 0, comma 100 and a closed interval, which is 0, comma 100. What is the difference between these two when I write it like that? Can someone tell me?
It's Gayatri.
Yes.
In open interval, we don't include 0 and 100 in that range. We start from 1 and go up to 99. And
Okay.
in closed interval, both upper limit and lower limit are inclusive. Like we start from 100 and go, oh, sorry, we start from 0 and go up to 100.
Yes, that's correct. So I'll just repeat what Gayatri said. In what Gayatri said, that when I write close interval 0 and 100, both 0 and 100 are included in this set of numbers. Whereas in an open interval, anything but 0 and 100, and numbers between 0 and 100 except 0 and 100 are included. For example, you can have something like 0.0001 also a part of 0 and 100, but not this. Okay, you can't have something equal to 0 part of your open intervals. And there are different ways also in which you can write numbers. For example, I can also write 0, comma 100 close interval, which means 0 is not included, but 100 is included in your data set, and anything in between that is also included. I can write something like, just for completeness, I can write 0, comma 100. Sorry. So all these are different ways in which you can write intervals. Okay. So basically, a circular bracket like this indicates open intervals, and a square bracket like this indicates closed intervals. Now coming back to the question itself, the question is given uniform distribution between 0 and 100 close interval, what is the probability P for any point between 0 and 100? What is the probability, do you think? Just what do you think the probability is for a point between 0 and 100? Anyone?
0.01.
Why do you think that is?
Because that's a formula of probability, like number of samples for which we are counting upon total number of sample size, like 1 upon 100.
Yes. That's a way of looking at it. Okay, and that would be correct if 0 and 100 included only numbers which are whole numbers. That is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, like that. But here, when something is written like this, it actually includes all real numbers as well. Okay. Now, when you say, when we come to the aspect of real numbers, what are real numbers? Anyone? So real numbers are basically anything that can be written down as a fraction, okay, and it has no imaginary component. So just for simplicity's sake, any number that you write without an imaginary form is a real number. For example, uh, 0 is a real number, 0.1 is a real number, 0.001 is a real number. So anything that lies from minus infinity to infinity is a real number. Okay, just for simplicity's sake. Now, when I say that what is the probability of a point, when I ask what is the probability of a point to lie between 0 and 100, what you need to do understand is that a point has, so when you calculate probabilities, it is nothing but the area under the surface. For example, this is a uniform distribution, right, from between A and B. So the probability of any point lying between A and B is this, the area under this. If I just shade this, for example, yeah, if I just color this and anything inside this blue line, the area of that is the probability of getting a point between A and B, okay? But when I say a point, for example, if I add a point here, yeah, if I add a point here, okay, it has no area inside underneath this. There's no area, so it has no probability as such. Okay, so for any point estimate, okay, for any point estimate in any distribution, the probability of that point value occurring, for example, this point value could be something greater than p here, it's 0. Okay, so the answer to the second question as to what is the probability of a point between for any which lies within a standard within a uniform distribution is 0 actually, because there is no area beneath it, has no area. Did everyone get this? It's slightly difficult to understand, but I'm sure you have done area under the curve, right? So when you integrate also, so integration is nothing but finding the area under a curve, okay? And a point has no area under it. So the probability of a point occurring between 0 to 100 is actually 0. Why this is so? Let me come back to real numbers. So the number of real numbers between any two numbers, any two real numbers is actually infinite. You can have infinite numbers. For example, uh, like I was saying, between 0 and 100, between say even just between 0 and 1, or say yeah, between 0 and 1, you can have infinite real numbers like 0 0.1, 0 0.001, 0 0.001, and so on. So all of these can correspond to a point, okay? And the area under them will be 0 for any value between 0 and 100. Okay, that's why you can always calculate area between two given points, but not area just below a point. For example, this point has no area under it, so you can't calculate it actually. Is this clear to everyone why the answer to the second question is 0 and not
Yes, sir.
0.01? Yeah? Anyone has a doubt with this, because it's slightly conceptual that a point has no area underneath it. It's infinitesimally small. Yeah? Anyone? Please ask questions now, because it's not a very trivial answer. Most people would select 0.01 as the answer, but that's true only if the set of numbers between 0 and 100 were whole numbers. Actually, that would be 1 by 101 then, which is slightly less than 0.01. Yeah? Anyone? There is a question similar to this which comes later on in the assignment. We can discuss that and it can be made more clear. The third question is also mathematical. Given, I'll just add someone. Given a variance of a random variable, variance of x is 15 and variance of y is 6, and the variance of x plus y is 35, what is the value of the covariance of xy? Has anyone done this? And if so, I'd like to know how they did this. Yeah? You have to do slight derivation for this. It's not very difficult actually. Maybe I can jump to the answer since no one's answering. So let z equals x and y, okay? Now variance of z, which is x plus y, is nothing but covariance of z with itself, right? This we know. We did it in 2 classes before also, where variance of z can also be written as covariance of z with z, the variable itself, which is nothing but covariance of x plus y with comma x plus y. Now this thing can be written in the following manner, because which is basically covariance of x with x. You need to just multiply, okay? Multiply the symbols. It does not mean actual multiplication. You just associate the symbols in a multiplicative manner. So covariance of x plus y with covariance of x plus y is nothing but this expression, which is covariance of x with x plus covariance of x with y plus covariance of y with x plus covariance of y with y. Is everyone clear with this step?
Yes, sir.
Yeah? Anyone else? I hear only one person speaking up. If anyone, I don't know, silence can mean two things. Either you have understood everything or nothing at all. Yeah? Anyone?
Yes, sir.
Okay, great. So then when we simplify this thing, you know, covariance of x with x is just the variance of x. Okay, we used this earlier as well, so we're just using that property again. Covariance of y with itself is again variance of y, and covariance of xy is nothing but is also equal to covariance of yx. They are interchangeable. So if we add that, it becomes 2 into covariance of xy, okay, because covariance of x and y is equal to covariance of y and x. It's the same thing. Now given this result, we get that covariance of xy is nothing but variance of z. Variance of z was here. I'm just rearranging the terms. Minus variance of x minus variance of y, the whole thing divided by 2, right? And I'm just simplifying this. If I write variance of z here equals this, yeah, and I just rearrange the terms, I get this. Okay. Now variance is nothing but variance of x plus y. and this is given to us. It's 35 in the question. So variance of x plus y is 35, variance of x is also given, variance of y is also given. We just need to substitute the values. So 35 and variance of x is 6, variance of y is 15. So 35 minus 6 minus 15. The whole thing divided by 2 is nothing but 14 by 2, which is 7. So 7 is the answer for question number 3. You just have to expand this thing, and once you get that result, once you get this result, you have to just substitute the values. Okay, is that clear? It's slightly mathematical, but it's simple if you see what we have done. Is this okay? Anyone? Anyone with doubts? Or how we did this? Any clarifications required or regarding concepts that we used? Speak up, please.
So can you please give us 2 minutes to understand this?
Okay. Okay.
By ourselves.
Yes. Okay. I'll just leave it on the screen for 2 minutes also. I'll be sending all these notes to you also. Are these notes accessible by the way? Because I've been uploading them. I hope you guys can access these slides. Is anyone having problems with this? Please let me know now. Yeah? Can you access these things? This material? Please let me know.
So you upload it on YouTube, right?
YouTube, and I've also uploaded the slides on a link which is shared to you all. With the
Yes, sir.
slideshow.
We get the notification via the discussion also.
Okay. Yeah. So the PPTs are also
The announcement sessions we get it.
Okay. So yeah. Please let me know if any of the material is not available to you. I'll make it available as soon as possible. So is it okay? Can we move on? These people have.
Yes, sir.
Sir,
Yes.
can you please again explain the steps after implies?
Implies. So what I've done here is basically rearrange this. So variance of z, I've taken variance of x and y to this side. It becomes minus variance of x minus variance of y.
Yes.
And then divide by 2. So which is nothing but covariance of xy. I've just taken everything except covariance of xy to the other side.
Okay, sir, understood.
Yeah?
Yes, sir.
Okay, and then I've substituted values. Z is nothing but x plus y. So I've just substituted values and then done that. Okay, the next question is, oh sorry, this should not be. What is the expectation for a binomial random variable where n equals 10 and p equals 6? It's 0.6, sorry. Anyone? Anyone, please? What is the formula for that?
So I think it's NP,
Yeah.
which should be 6, but
Yes.
I think the option is wrong. It's 60. It's given 60.
Yeah. So I think the options are wrong for this question. I don't know how this is going to be resolved. I'll write to the people who have made the assignment. I'll not take this assignment. But yeah, the answer should be 6. And the mean of a binomial random variable distribution is NP, which is 10 into 0.6, which should be 6, not 6. So there's no 6 in the options. So just write to them regarding that. But yeah, that's the answer for that. Next question is quite simple. We have been doing it quite a few times along this course. What is the probability distribution in case of a rolling dice? Anyone? We've been doing this.
Binomial distribution.
No, it's not binomial.
Normal.
No? Why is it binomial? Tell me. Can someone tell me? Why is it binomial? Someone said binomial. Can you tell me? Why is it binomial? It's a uniform distribution, no? And it's 1 by 6. Yeah, we've been doing this. You can't be confused. So the answer to that is uniform distribution, and the value for that thing is 1 by 6. It's the same for x between 1 and 6, where x can take 1, 2, 3, 4, 5, 6. So it's a uniform distribution. And the probability of each event happening is 1 by 6. Binomial distribution is very different, and it is also related to this, but in a very different form. It is actually the number of successes is actually modeled as a binomial distribution. For example, if I throw a die 10 times, then the probability of success has a binomial distribution. But just rolling a die has a uniform distribution. There's a distinction between those two. I urge you to read the Wikipedia page on this, on what binomial distributions are, what uniform distributions are, what all of these normal distributions are, and so on and so forth. Okay, please do that. So yeah, the answer to this question is, in the case of rolling a dice, is basically a uniform distribution. Yeah, is that okay with everyone? Anyone has a doubt regarding this?
It's clear, sir.
Yeah, the value of that probability is 1 by 6 for a 6-sided die. If it's a 10-sided die, it's 1 by 10, and so on and so forth. For a normal distribution, which of the following statements are true? Anyone? This is simple, we have done this before. Anyone? Can you speak up and let us know your name and what do you do, where you are from, please?
So my name is Iman Ghosh, and I am a research scholar at Department of Anthropology, Guwahati University.
Nice, that's very nice. Yes. So yes, Iman Ghosh. Am I pronouncing it right?
Yes, sir.
Yes. So you are right. For a normal distribution, the mean equals median equals mode. That's only because we have done this. Why is it so? Because normal distributions are symmetric about the mean. So if this is the mean, they are symmetric. So that means the median is also the same. And it has only one peak, which is also at the mean. So mean equals median equals mode for a normal distribution. Uh, Next question. For a Poisson distribution, which of the following statements is incorrect? Actually, it should be, yeah. Which of the following statements is or are incorrect? Anyone? So, so it's slightly mathematical to prove this, but without proving, if I state it as a fact, the variance and the mean are the same for a Poisson distribution. So this is actually correct. These two are incorrect. So variance greater than mean or variance lesser than mean, that's incorrect. Variance is actually equal to the mean. So I think this question is framed slightly incorrectly, because we can choose only one option. It should say which of the following statements is correct, and that's nothing but variance equals mean. Okay, I'll write to the people regarding this. How is this so? It's slightly mathematical, but we can do that quickly. Okay, how is the variance equal to mean for this? Requires a bit of math. If I go to full screen, yeah, let me use my pointer. So you know that this is a Poisson distribution, right? E power minus lambda into lambda power x by x factorial. And this is how you calculate expectation of the Poisson distribution. That is summation of x into p of x comma lambda. P of x comma lambda is nothing but the probability distribution. And it's slightly mathematical. I won't go into this. I'll just, yeah. So you can, once you write this, you can write this as you can take the lambda and e power minus lambda out and expand this, okay, which is this. And when you simplify this expansion, you get this, okay. This is lambda squared by 2 factorial and things like that. And when lambda is very small, you can exclude all these other terms. This is comes from Taylor's expansion. I'm just mentioning terms to you, but because since it's not important from the point of view of the course, anyone who's mathematically inclined can ask me questions now or later. So we neglect these terms because they're very small, okay, and we are left with just lambda into e minus lambda and minus lambda e power minus lambda, and when you simplify that, you just get lambda. And variance is this, we know it's ex square minus e into x square, and again you just have to multiply x square with the probability distribution, and then you do a little bit of simplifications, and again use Taylor expansion here. You get something like this, and when you simplify this, you again get lambda. Okay, I think it's not visible properly. Yeah. So you get lambda square plus lambda, and you get, lambda variance is variance is also lambda. So when you subtract x square, which is lambda square plus lambda, from ex the whole square, which is lambda square, you just are remaining with this lambda. Okay. So by that way, the variance and the mean are the same for a Poisson distribution. Okay. We won't do the math here since it's more intensive, but just remember, for a Poisson distribution, the variance equals the mean. Okay, for a Poisson distribution. Okay. Anyone having questions here? If you want clarifications regarding the math, we can do that as well. But I don't think it's necessary for this course. Okay. The next question is again, it's an old question coming back in a new form. We did this earlier. If x is uniformly distributed from 0 to 100 close interval, what is the probability of x now lying in the range 20 to 80? So it's not a point anymore. So x can lie between 20 to 80. So it's not a point, it's actually a range. So what is the probability? Can someone tell me?
So 0.3.
Yeah. So it's actually not exactly 0.3, it's 0.33, because what you have to do is you have to calculate the range of 80 to 20, which is 60, right? 80 minus 20 is 60, and divide it with the range of the uniform distribution, which is 200, because 200 minus 0 is 200. So if you do that 60 by 200, you get 0.3333. It's a recurring fraction, which is equal to 0.3 here for simplifying things. So it's basically 60 uh, 60 divided by 200, which is 0.3. How did I get 60? I just did the 80 minus 20 divided by 200 minus 0. Yeah. Yeah, which is equal to 60 by 200, which is equal to 0.33. Does anyone have a doubt with this? Yeah. The answer to this question? Anyone? Please speak up, because it's very simple but very fundamental problem. Now we are not calculating probability of point. We are calculating the probability of a range within the distribution. The range goes from 20 to 80, which is, so the range is just 60. And the entire, that thing lies within that 0 to 200. So it's 60 by 200, which is 0.33 is equal to 0.3. The next question is the mean of an exponential distribution. What is the mean of an exponential distribution? Anyone? Please let me know. So all these things are slightly intense when you derive mathematically, but you can just remember it as a matter of fact. What is the mean of an exponential distribution? Anyone? Can someone tell me no? Let me know, or
1 by lambda.
yes, it's 1 by lambda. And how that comes is basically, again, mathematically intensive. So how do you get the mean of a random variable? You multiply x into the probability distribution and integrate it. So the probability distribution for an exponential is lambda into exponential of minus lambda x. Okay, that is a probability distribution. You multiply that with x and you calculate from 0 to infinity, you integrate it. So you have to integrate this term. And you have to use something known as integration by parts. I'm not going to explain that here since it's beyond the scope. But once you integrate and do a little bit of math, you get 1 by lambda. Okay. If people who are mathematically inclined want to know how these two steps come about, I can let you know now, or otherwise it's just beyond the scope of this course. But yeah, the exponential. So all of these things can be derived mathematically in an exact manner, which is happening here. So the mean of an exponential distribution is 1 by lambda. It's not just coming out of thin air. You can actually solve this. Okay. Okay. And now coming to the last question. When lambda equals np, under what circumstances does the Poisson distribution become similar to a binomial distribution? Anyone? Again, this is very mathematically intensive. I did this in a math course long back. I don't urge you to look at this because it's slightly difficult, but you can know this as a fact. Okay, when lambda equals np, so np is basically, Poisson distribution, right? How the Poisson distribution looks. It is this. Is basically, we did this. Yeah. So it's basically this part, e power minus lambda into lambda power x by x factorial. That is the Poisson distribution. Okay. And when lambda, so the question is, when lambda equals np, when does this Poisson distribution tend to a binomial distribution? And that actually happens when your n is n is n is small and p is large. Okay. Yeah. So when n is small and p is large, you get a binomial distribution. And when n goes to infinity and p is very small, you start getting a Poisson distribution. Or am I saying it the other way around? Let me just check. Let me just check. I think I'm telling it right, but just give me 2 minutes. Yeah. So for larger values of n, for large values of n, a binomial tends to a Poisson, but for small values, it's the other way around. Okay. So Poisson becomes a binomial when n is small and p is large. So it's this answer. It's very mathematically intensive. So when you have a small number of trials and the probability of the event occurring is large, it's more like a binomial distribution. But when your number of trials is very high and the probability is small, the distribution becomes more like Poisson. Okay, you have to do a limits and whatnot for this. Slightly more involved. But yeah, so the answer to that is n is small and p is large. Yeah, anyone with questions? I know this is slightly difficult and it requires actually a lot of math, the last two questions, but you can remember this as just facts for now. Okay.
Can you repeat it? Actually, I don't understand.
Yeah. So a Poisson distribution, actually it's better said the other way around. A binomial distribution tends to become a Poisson when n is very large and p is small. Okay. Whereas a Poisson tends to become a binomial when n is small. N is the number of trials and the p is probability of an event occurring. When p is large and n is small, a Poisson becomes a binomial. Yeah. For example, imagine you you have a 2D board, okay, in front of you, and the entire board is divided into small squares like a grid, and you throw a dart at the board. The probability of the dart hitting a particular square on the board is actually Poisson if the board is very large, but if the board is small, it becomes a binomial distribution. Yeah, I know it's slightly conceptually difficult, but yeah, when you have a large number of trials and the probability of uh, some an event happening is small, then it becomes a Poisson. Is that okay? For example, okay, let's do this. Let's do this slowly. Suppose you have a board in front of you, okay, and you divide the board by drawing horizontal and vertical lines, so that you get a lot of squares. Okay. Now, the size of the squares is constant throughout; it's uniform. Now, when the board is small, you have small number of squares. Okay. So the probability of you hitting a particular square on the board is pretty high because there are small number of squares only. You'll have like 30 or 40 squares. Now imagine the board to be really large and you have the same size squares, but they are now a lot more because the wall is much bigger, the board is much bigger. And then you throw a dart. The probability of you hitting any particular square on that large wall is more Poissonian because you have a large number of squares and the probability of hitting a particular square becomes very small because there are so many squares that you can hit. So that becomes more Poisson distributed than binomial. So there your n is large because you have large number of squares and the probability of hitting a square is really small, p is small. But when your p is large and n is small, then it becomes a binomial distribution. Like when you throw a dice, okay? When you throw a dice, the probability of you getting three successes, for example, like three threes, for example, follows a binomial distribution because you have only, say you throw a die 10 times, so your n equals 10, and the probability is actually pretty high because it's not very small. You can get three threes when you throw a die 10 times. And there's a way of calculating the probability. We won't do that now, but there it's a binomial distribution. Anyone with doubts regarding this? It's theoretical. I can't explain how this is mathematically true because it requires a lot of math.
So there's something in the chat box.
You have a question? Yeah, sorry, I can't see the chat box when I switch screens. Uh, no. So it's actually, what is this? Yeah. In the notes, it's given that Poisson distribution approximates a binomial closely when n is large and p is small. No, it's actually the other way around. Okay. I think that's some error. Wait. Yeah, for large values of n, it should be the other way around. Please ask someone, because this is what I'm saying is true mathematically also. I can't show you that. Maybe you can ask some, just write in the discussion forum that the reverse is was said to be true, but it's not. Okay. For example, I can show you somewhere maybe. I think you can see my screen now. Approximation of binomial to Poisson. Okay. Yeah. So see, this is some forum, but this is true. Yeah. When the value of n in a binomial distribution is large and the value of p is small, the binomial can be approximated by a Poisson distribution. Okay. So please check this. It should, what I've said is correct, and if the notes mention otherwise, do correct it. Okay, this is something I learned 7 years back and I still remember. So yeah. Okay.
So the final answer would be when n is small and p is large.
Yeah, when n is small and p is large, a Poisson tends to become a binomial. And when n is large and p is small, a binomial becomes a Poisson. Okay.
Yeah.
Great. Yeah. Anyone has any other doubts or clarifications regarding this assignment?
Yeah, could you re-explain the fourth question last comment?
Sorry, can you please repeat? I couldn't get you at all. Someone?
Can you re-explain the fourth question? I was a little confused.
Okay, there are two people talking. Maybe one of you can talk. Maybe someone said fourth question. Yeah.
Yes.
Fourth question. Yeah. So yeah, the answer to this is n into p, which is 10 into 0.6, which is equal to 6, not 60. So yeah, the options are not correct. There should be an option called 6 also.
Yeah, exactly. What we do with that?
You can write it on the discussion forum, and people will look into it. People who are, I don't correct your assignments, they get automatically corrected, but you can write this in the discussion. I'll also write to the people who create these assignments. Yeah.
I think there was one message in the discussion forum about this.
Okay, so actually the fourth question and the last question, yeah, actually the last question has the option. Yeah.
Right.
Yeah, you can just check. I think all these queries are usually answered on the forum. So yeah, if not answered, you can ask me again in the next class and I can forward it. I'll also write to the people in charge regarding this. Yeah. And for example, in the first question, you can have multiple answers. For example, normal and uniform have the same mean and median, but you can select only one option. I tried doing multiple, but even I couldn't. Yeah. Okay. Yeah, someone else had a question? Someone else? Yes.
I think, I think my voice sort of doubled initially, so
Okay.
it might have to. So I just wanted to confirm the answer for the eighth question.
Eighth question is 0.3. 0.3. 60 by 200 is 0.33, which is more closer to 0.3. So 0.3 is answer.
Yeah.
Someone else? Anyone else?
Sir, can you give us some idea about what kind of questions will be asked in the final examination, which is supposed to be held on 25th?
25th of September. I have no clue. I really have no clue. So I think it's everything to do with whatever you have learned. It'll be very similar to your midterm exam.
I mean, will this be according to this assignments, or those derivations will also come, which videos they upload generally?
I don't think derivations will come directly, but you'll have to use the derivations to answer some of the questions. For example, you saw, no, like this answer here came from the derivation. You can't remember the formula to this. You have to derive the thing and then answer it. You have to derive an expression from covariance with respect to these two values and then get the answer. So yeah,
So,
even
so basically, the questions will be like those of the assignments.
yes,
Okay,
yes.
sir. Thank you.
I think it'll be mostly multiple choice, but you'll have to use the principles of all this derivation. Yeah, it's difficult to derive the mean of an exponential distribution, but it's you have to at least remember what the mean is and what the exponential distribution itself is, not just the mean. So, what is the expression for exponential distribution? It's this, right? Where is it? Yeah, it's uh, lambda into e power minus lambda x. That's the expression for an exponential distribution. So you need to know all those things. Otherwise, you will not be able to solve a lot of questions. So you need to know what the probability, what the expression for Poisson distribution is, what the expression for binomial distribution is, and all that. Yeah. Anyone else?
Yeah, I have one more question.
Yes.
The third one, I was not getting the correct answer, like as discussed. Can you please show the working again?
Yeah. So you got this right. These steps, maybe. Yeah.
Yeah, this is fine.
So then when you get this from that. Okay. Now you just have to substitute values. You know, variance of z, which is variance of x plus y, is given. That's 35. Variance of x is given as 6, variance of y is given as 15. So 35 minus 6 plus 15 is 14, right? 14 divided by 2 is 7.
Okay. I think I messed up with this one. I took it as 14 instead of 7, instead of dividing it by 2.
Yeah, you have to do it because you get 2 into covariance of x, y. Why? Because
Correct, correct.
covariance of x, y and covariance of y, x are the same. So you take twice of any
Right,
of
right.
this. Hmm. Anyone else? Anyone else with any doubts regarding this or the previous assignments or anything in the course so far? I urge you to work these out, write them down, write the distributions down and do it. Yeah, do it on pen and paper. It's always better. Yeah. Okay, if there's nothing more from your side, we'll meet next class, next Tuesday, again from 6 to 7, where we'll discuss the next assignment. Okay, that's it from my side, and thank you all for listening. Please let me know. Yes, yes, tell me.
10th, last question.
Last question, yes. Yes. So we discussed this. The answer to this is when given lambda is equal to NP. So lambda is that you have to go back to what lambda means in the distribution of Poisson and binomial. So when n is small and p is large, it becomes a binomial distribution. Whereas when n is large and p is small, it becomes a Poisson distribution. So the question is basically asking when does a Poisson become binomial? That is true when n is small and p is large. Yeah. I think your notes mention it the other way, other ways, but that's not correct. Just check. Okay. So the answer to this is n is small and p is large is when Poisson becomes binomial. Yeah. Is that okay? Anyone with more further clarifications on this? Okay. Yeah. Someone, I heard a mic murmur.
Second.
Second question. Yeah.
Yeah.
So when you were asked to calculate the probability of just a point event, a point, right? It is zero because the area. So what is probability? It is the area under a curve. Okay. For a point, you cannot calculate an area under the curve because it's just a point. There's no way you can't integrate a point. So for example, the area under this blue point here is zero. You can't integrate anything under a point. Whereas we can integrate under a region or under a range from A to B, you can calculate the area of this blue square. So that will be the probability of a value lying between A and B, which we did, no? We calculate the probability of lying of a point lying between 20 and 80 in the one of the questions. So that was something that we got a value that's 60 by 200. But for a point, it's just zero because there's no area under a point. It's zero here. Yeah, is that okay?
Yes, sir.
Okay, great.
Fourth.
Fourth point, we did this at 6, it's n into p, 10 into 0.6, which is just 6. There's no correct answer in the options, but I think people have asked for some clarification on this on the forum. But yeah, the answer should be 6, not 60. If n was 100, then yeah, the answer would be 60. But since n is equal to 10, the answer is 6. Yeah, anyone else?
Please repeat 5, 6, and 7 once, please.
Okay. The answer to the rolling of a die, what kind of a distribution it is, it's a uniform distribution. The value of that, the probability is 1 by 6 for x between 1 and 6 because the die has 6-sided face. So it's a uniform distribution. 6 is, we have done this before, normal distribution. For a normal distribution, which of this is true? It's this, where mean and mean, all the three are equal, mean, median, and mode, because it's a symmetric distribution. And yet the seventh question also, which of these is incorrect? Both these options are incorrect. For a Poisson distribution, variance equals mean. So you can either select this or this, variance greater than mean or variance lesser than mean. This is the correct option. That is variance, correct option is in, this holds true for a Poisson distribution. The variance and the mean are equal. So what is incorrect? Either variance greater than mean or variance lesser than mean. There's some typo also here. Yeah. Anyone else? Please look into the YouTube video that I will upload soon, or the material also. I'll upload the slides for the which have the solutions for this. As in, they don't have which option is correct. It just tells you what the answer is. Yeah. Okay. Okay. So if there's nothing else from your side for now, I just close this session and we'll meet next Tuesday at 6 p.m. And please, yeah, do the assignment, next assignment until then, and let me know if you have any doubts in the next class. That's all from my side for now, and thank you so much for attending this session. Yeah, thank you so much.